Good morning and welcome to the Management Under Construction podcast. I'm Brad Wyant.
And I'm Dee Davis.
Today we're talking about construction productivity and organizational structure. This is sort of the informal thesis presentation for a program that does not have a thesis. I am nearing the end of my MBA program. I graduate 2 weeks from today. I'm a little disappointed the program doesn't have a thesis. The reason that I came to business school was to try to explore the issues that I was seeing in construction from a productivity standpoint, from an organizational structure standpoint, to understand what's going on and have some better frameworks to analyze the challenges that we face in construction. But even though we don't have a thesis, I'm going to try to combine a lot of the different learnings I've had through my coursework to present what I think is an analysis of what's going on in construction to prevent us from increasing in productivity the way that other industries have in the past 60 years, and how we can think about these problems as we try to approach them in the future. Maybe some solutions here. Before we get into the depths of that, I want to let Dee talk about some of her observations as far as organizational structure and productivity in construction go, and then I'll share some of my own.
What I have seen in my what feels like a very long career, I guess, when I start tallying up the years, it shocks me. The time has gone so fast, but I've had nearly 30 years in the industry. And what I've seen over the years is definitely massive changes in technology available to us in the industry, adoption of that technology, safety, the safety stories I could tell you from when I was a framer out in the field, hanging off the side of a building in my shorts and tank top, no hard hat. My sunglasses were my safety glasses. That is really not something you would ever see on a commercial job site these days. I've done the research also, and construction productivity is flat. I think we even mentioned it in a previous cast. Compared to other industries who have adopted technology, productivity is relatively flat in construction. So the question is why? How come we have done all these things apparently and productivity is still relatively flat? So I'm going to throw out my thesis on why I think that is. I think safety has a lot to do with it. Our progress in safety over the years and what is considered acceptable in safety has changed dramatically in a good way, not in a bad way, but in a good way. Every once in a while we get into the bubble wrap conversation. I call it the bubble wrap conversation, when you're having a conversation with a safety person and you get frustrated and you say, fine, I'll just wrap my entire crew in bubble wrap then. Can we take it too far? Yes, perhaps sometimes we can, but sending people home to their families safely is a paramount importance and responsibility as a construction professional. So I think safety has slowed our productivity down to some extent. Sloan, is that a word? That's a name. That's not a word. Slowed us down. Technology, while I have seen leaps and bounds of technology adoption in the years that I've been in the industry, started out in the industry, everything was in paper, everything was on the phone or in person. I mean, we barely were using computers we have Bluebeam now, we have BIM, we have laser transits, we have all these things at our disposal. 3D technology out in the field to build something in a model and project it 3D so we can see what it's going to look like when it's all done. We have this amazing technology, but the adoption of that technology is extremely painful and time consuming and expensive. Not only is the technology expensive, but it can take years for your people to get up to speed with some of this technology. So something simple like using a laser transit to lay out on a deck. I actually was very skeptical at the very beginning of that. I was working for a company who was an early adopter of a lot of this technology and went through all the growing pains. I raced an experienced foreman with a tape measure against this technology to see which one was faster. And at that moment in time, the experienced foreman with the tape measure was faster. That's no longer true. But at the time it was. I was just curious because it felt like it was taking longer. And I thought, God, I feel like we could do this faster the old-fashioned way. It's okay to adopt the technology, but let's make sure that we're actually gaining ground here out in the field. So things like BIM, same thing. It took years and years and years of using BIM to get good enough at it and fast enough at it and coordinated enough to really start making production gains in the field. So things like that, I think, are slowing us down and slowing down the overall productivity and the fact that we don't have as much repetition as you think we do. in construction. We've got some productivity gains out of really leveraging what we can in a fab shop for getting welds out of the field, getting prefab out of the field and into a shop environment, and then shipping it and shipping things in larger pieces out to the field and doing as little in the field as we can. But still, the cost of operating that shop sometimes is more than what it actually would save you in the field. I've done the math on a bunch of these over multiple projects. The shop cost, and I'm using air quotes for people who can't see us, the premium put on a shop for a lot of contractors is another profit margin area. It's a hidden profit margin. And if you're throwing 20, 30, 40, $50 an hour onto a shop premium, it's actually costing me more to do it in the shop per hour than it is to do it out in the field at that point. So I think that's some of the reasons, those are my theories as to some of the reasons why we're not seeing the big production gains out in the field.
And I think that there's something really interesting to delve into there. Technological adoption is slow in the construction industry. That's one of the things that management consultants hang their hat on. Oh, if construction industry would just adopt technology faster, they'd be getting faster more quickly. But like you just talked about, there's so many different challenges in a job site environment to adoption, and you don't get to do the same thing every time. Compare that laying out task and how different that is going to be per floor, how different it's going to be per job, to putting a robot in for a person to attach a steering wheel to a car. They're going to make 1 million of that car. That robot gets 1 million tries in the same exact place at the same exact task to be efficient. And then on the next car, it's going to be perfect every time because they're going to have worked out all the bugs. There's so many more bugs to work out. There's so many more environmental challenges and differences from implementation to implementation in our business that adoption is inherently going to be much more challenging. So when people say, oh, well, we can make construction leaner, let's all go get our Six Sigma, whatever the lean certifications are, I'm always like, that person doesn't understand this business. If you're thinking about things in a lean manufacturing environment and trying to apply them to construction, that's not necessarily going to apply as readily as it does in a controlled manufacturing environment. But my observation that really turned me towards this topic came when I was much younger, when I was on a quote unquote design build. And I'm using air quotes again here for people not watching. It was a design build project. We were brought on as the general contractor to work with the architect, and I was working as the self-perform carpentry division's project engineer on an exterior wood facade system. And my foreman was telling me, hey, this detail's not going to work. Here's why. I went down into the rabbit hole. I found a new detail. I designed it with some experts. I worked it out with my foreman and brought that solution to the architect with a description of why the original system wouldn't work. And I later found out that architect had thought I was being totally precocious and presumptuous to come at her and challenge her work in this way. And the lesson I learned at the time was there's a right way to communicate a solution to a problem that somebody hasn't realized is a problem yet. And that you need to be respectful when you have that conversation. But looking back on it further as years went on and what design build is supposed to mean in the construction environment, it's supposed to mean that we're all each other's partners in the contractor-architect relationship and that we're working together to design and build as a team without there being this supposition that design is exclusively the architect's domain and that construction is exclusively the contractor's domain. And for her to have had that reaction of, well, what are you doing stepping on my toes? My design is perfect. How dare you? Is emblematic of both the history of the architect-contractor relationship, the culture of the division of expertise that we've built into our business, and the territorialness that has created in terms of the professions that we experience. So to put it shortly, my thesis is that the combined challenges presented by extreme specialization, contracting hazards, and the challenges of implementing advanced technological solutions all combine to prevent the construction industry from being more efficient. And I kind of want to break down how I've gotten there and how we've gotten to where we are. Going way back to the origins of capitalism, to the origins of the system that we work in the United States and in other countries abroad, capitalism is in part predicated on the idea that specialization breeds improvements that would not otherwise be possible. Adam Smith talks about this in The Wealth of Nations, the book that he wrote that a lot of people herald as the first time anyone spoke into truth the meaning of capitalism. It gives the example of a pin, one of the most simple things you could ever design, a nail pin. And that it used to be one pin manufactured by one person was a very difficult challenge for that one person to overcome. There are all sorts of different specializations that person has to undergo to learn how to manufacture that pin. But if you have an assembly line, if you have a group of people working to make that one pin, each specializing in their own part of making that pin, all of a sudden 10 people can make 1,000 pins in a day as opposed to one person making 10. The ability of a group working together but specializing in their own disciplines makes it easier to be more productive. So take that into the future and into where we are now, and let's talk about a more modern example of specialization. In the early 70s, Taiwan, which had been separated from China by that point, was trying to figure out what their economy was going to be. They were struggling. They didn't have a lot of advanced manufacturing on their island. They were trying to understand how they were going to become a global player and fend off the economic and political threat from mainland China. And they decided to send a bunch of people to Caltech and MIT to specialize in manufacturing and developing semiconductors. And by 1974, they were making a deal with RCA, former music and then chip manufacturing firm, to produce all of their silicon chips on the island of Taiwan. And by 1989, they're producing not just all of RCA's chips, but a bunch of other chips for a bunch of other companies. And by the mid-2000s, they have more semiconductor manufacturing than any other country by far. So when we talk about things like the CHIPS Act, that's what's going on. That's where that started. Taiwan decided to double down, to put all their chips on one number at the roulette table and say, we're going to be the best in the world at chip manufacturing, and the rest of our economy will follow. And that worked out really well for them. They've become a very wealthy nation as a result of that. They've created for themselves a very, very competitive strategic advantage by specializing that way. So when we look at the way the world is right now with free trade and specialization, those two things depend on the freedom to contract with other parties and the belief that those contracts will be enforced if they're broken. Taiwan is not going to make a contract with RCA, an American company, to produce all of their silicon chips in Taiwan unless they feel that there's an international court that they are going to be able to use to attack RCA if they renege on that contract. If they say, just kidding, we're going to do our own thing, we're not going to pay you to take on all that investment. So that's one of the big facets of what's been going on in economics in the past 200 years that has led us to this point we're at now in the construction industry. Any thoughts or reactions there so far, Dee?
It makes sense. I mean, that's where the World Trade Organization comes in, that international court, if you will. That's how that came about, to free up the world trade between countries and provide some structure there. The kind of manufacturing we're talking about is true manufacturing. So 16,000 or whatever classification you're in of repeat manufacturing, just like car manufacturing, chip manufacturing, that kind of stuff, which is, I wish we could take advantage of that in construction. Like you're saying, we can make 1,000 pins a day instead of 10 pins a day. So I'm going to be really interested to see how this evolves to applying more directly to construction. Manufacturing is a fascinating world. It really is. I get a lot of joy out of working in the manufacturing industry.
Me too. I mean, just to be able to watch these factories come together and then watch these people learn as they go. Let's apply that sort of paradigm to what's happened in construction in the last 300 or 400 years. We started building simple buildings where there wasn't a ton of specialization. Everyone was doing roughly the same kind of tasks. But in the late 19th century, in the late 1800s, we see unions for the first time. And those unions are setting their own internal minimum requirements for their members as far as proficiencies. They're training people through formalized apprenticeships. They are furthering whatever discipline they've chosen to specialize in a way that we didn't see before. Mason experts are passing down their expertises to their children, to their friends and family, and they're creating a craft in a way that wasn't formalized and wasn't uniformly moving forward until this point in time. If somebody out there is a history buff and wants to correct me on that, but that's what I found. Go ahead, Dee.
Well, I was going to say that the predecessor to that was the master builder. When we're talking, go back to the cathedrals and things like that, those were master builders. Those people designed and built all of it themselves and just directed. They were the designer, they were the superintendent, they were the engineer. They did everything. You got to figure how many people can actually do all those things. Very few. So the specialization of the trades was a productivity enhancer. because now we're opening the doors to all kinds of people who can come in, and I can do that one thing. I can do mechanical, electrical, plumbing, masonry, whatever the specialization is. It's much easier to teach people a limited set of tasks than it is to teach them how to do absolutely everything.
Right. And that's what we see between that time and now, is that buildings become vastly more complex, vastly more sophisticated, and better. They start to be able to achieve construction deadlines at a much more rapid pace. I went to Ireland before I started the MBA program, and there was a church we visited where we went deep for 2 hours with an expert who was a huge history buff on this specific church. And he talked about the near century it took to build this church that was smaller than most buildings you or I ever built, D. And that the architect thought of just getting like the job to do the work as his life's ambition and achievement, just doing this one building for his entire life and going deep into the history and designing this specific stained glass window to have these meaningful metaphors and allegories of the Christ and all that. It's just like that was the only building he ever did. It's a gorgeous building. It still stands, thankfully, after all the bombings and things that Europe saw. But so specialization enables us to complete more, better buildings faster. And between the late 19th century and now, we have specialized into every conceivable niche. Now we don't just have somebody that does the glazing. We have somebody that does this specific kind of glazing. We don't just have the waterproofing contractor. We have the waterproofing for underground in this kind of soil contractor. We've got very, very unique individuals who have deep, deep experience in their area of expertise, but few marketable skills outside of that expertise, and are very often only on our job sites for maybe 2 or 3 weeks at a time to do that one very special thing and then go and do that thing at some other job site. So we've got operational excellence in some ways, and we've got professional training systems with a lot of rigor. The American union system in the United States is still very strong. But in the past 40 years, we're still flat on productivity. There are graphs that people have put out. There are data that they've gathered that proves that we are flatlining in terms of productivity. So what's going on still? Well, here's where I get into what I think I'd like to propose based on my analysis. There's a huge hazard of contracting problem, and I want to explain what that is based on the things I've learned here at business school, and then we can kind of dive into examples of that contracting hazard we've had in our careers. So there are 3 different kinds of hazards I want to talk about. The first is holdup. So holdup is a hazard of contracting meant to reflect the risk that you engage in a contract with somebody and then they just refuse to participate. So let's say you hire a mechanical sub to do a job for $500,000, and it comes to the day that they're supposed to be out on site, and they say, yep, we're just not going to come out on site unless you give us another $100,000. That would be an example of a hold-up contracting maneuver on their part, because they know that it's the day before they're supposed to come out on site and they've got you in a tough spot, but they're just exerting their leverage for no additional benefit to anybody. They're just holding you up like a robber. So the next one that I want to talk about, the next hazard, is perverse incentives. That you can create an incentive structure in a contract where one company can maximize their own profit while minimizing the others with outgrowing the pie. And so this would be an example where if there's some incentive structure aligned where there's some minimum performance and some maximum performance, there's an equilibrium that occurs where that contractor could do the bare minimum and make more money without helping the project out any. And that kind of thing happens a lot, we see. Penalties, I don't know if anyone's ever gotten this legal advice, but penalties are very difficult to enforce. A penalty clause that we would see often in the construction industry, the best example of that would be a liquidated damages clause. If a subcontractor fails to perform their work in the allotted time given in the prime contract schedule, then they could be responsible for the liquidated damages the prime contractor is responsible for because they failed to hit their dates. What the courts tell us, and I'm not a lawyer, this is not legal advice, all that disclaimer, I have no interest in being called into a courtroom for this podcast. Liquidated damages as a penalty are very difficult to enforce. Contractually, you can write whatever you want, but the case law does not support upholding a contract's liquidated damages or other kind of penalty clause in the court because of the way that the lawyers have figured it out. Dee, do you want to go into any examples of liquidated damages or your experience with penalty clauses in contracts and more about why that's the case?
Yeah, I've been on a lot of projects with liquidated damages clauses. I rarely see them enforced, and I think a lot of it is it's expensive to enforce. I've seen liquidated damages anywhere from $500 a day to $100,000 a day. It's scary to have it written into a contract. There's a lot of contractors that won't sign a contract with liquidated damages for obvious reasons. It's so complicated as to why something happened and whose fault is it, because that's really what you end up getting down to with a liquidated damage is, okay, did we miss the date? Yeah, we sure did. We missed it by 6 days. Why did we miss it by 6 days? Well, because this person didn't answer an RFI, because it wasn't in the design. Well, it wasn't in the design because everybody gets drug in, and it's very complicated, and you end up in court or in some version of negotiation, and it's just more trouble than it's worth for most companies. But there's also carrot clauses. It's very similar to liquidated damages. For every day you finish early, you get a bonus, is another way of doing that.
There was an example we went over in class very briefly in my contracting class about how difficult penalties are to enforce. Rivian, the electric vehicle manufacturer, had a contract with a seat manufacturing company for their vans. And one of the things they wrote into this contract was, if you, the exclusive provider of this seats for this van, fail to provide your seats, we're going to have the right to sue you for damages if we can't ship vehicles and get paid for them. And the seat manufacturer held up Rivian and said, well, we're just not going to ship them unless you pay us more money. And Rivian said, fine, bet, we'll sue you. And they went to court, and the court found in favor of the seat manufacturer because the liquidated damages clause in that contract, the penalty clause, was unenforceable, was not valid. So whenever there are penalty clauses in contracts to deal with, just as an aside, talk to a lawyer, see if they are enforceable. There are very specific kinds of penalties that are enforceable, but some are not. And I'm sure not the lawyer to tell you which are and which aren't, but it's very difficult to enforce penalty clauses, even if it is cut and dry, let alone when it's as complicated as it always is in construction.
Yeah, well, enforcing a penalty clause is one thing. Holding somebody for ransom, which it sounds like that's what was happening with the seat manufacturer. Give me more money or I won't perform. And you'd mentioned that before, hold up. I've never had that happen to me on a project, thankfully. Now, at the beginning, I've never had a contractor tell me, give me more money or I'm not going to show up. However, I've been held ransom many times on projects in the middle of performance, and not for money, but I call it the dangling the client over the barrel. Let me do this thing that isn't allowed per the spec or is incorrectly installed or whatever. Let me get away with it. Tell me it's acceptable or you're going to experience a delay. I get that happens a shameful amount of times on a project. It happens to me on almost every single project, it seems like, where I have some contractor, whether it's the GC or it's a trade contractor, that did something wrong. They made a mistake. They installed something they shouldn't have, installed it wrong material, something. I feel like they're getting the gun out and saying, tell me this is okay, or you're going to experience a project delay. That's the kind of holdup I see regularly.
Yeah, that's just so frustrating. It's like, it's been there on the drawings the whole time and you did it wrong. And now you want me to cover up your mistake or you're going to come after me. That's just that's the kind of thing that could keep somebody up at night.
Makes me very angry when it happens. And the ethics, it tells me an awful lot about that company and that person that I'm dealing with, especially if they've tried to hide it to begin with and I caught it or somebody caught it. And then they try to make excuses and then they try to hold you ransom.
Yep. Well, that brings us nicely into the last hazard of contract I want to talk about, which is the moral hazard. In construction, as opposed to other examples of complex manufacturing supply chains, we're often dealing with what feels like a one-shot sort of experience where we're going to contract with this company once to do this one job this way, and we're going to part ways and probably not see these same people again for a very long time if we see them at all. What we see based on behavioral cognitive data that I've seen in some of the classes I've been over is that when that kind of thing happens, people get a lot more selfish. People get a lot more cutthroat. People get less likely to collaborate. And it's because they realize this is my one chance to capture as much value as possible. In any kind of negotiation game where they test behavior. People are much nicer if they know they're going to play multiple rounds of that negotiation game with that person. And they're a lot meaner. They're a lot more cutthroat, a lot more selfish when they know that it's just this one time, and they will do anything in that one time to get as much as they can. I think that kind of thinking worms its way into our construction projects the further we get into them and the closer to the end of the project we get. If it's a long project, we're going to be with the same people for 2 years. People act pretty nice for most of the time. But then when you get to the end, people start to worm things. Yeah, I just need you to help me out and pay me on this change order. I know I don't deserve it, but I need it. Or I'm not going to be a friend to you for the rest of this thing. Or people just get crazy at the end of jobs. I'm sure people listening to this podcast who have been in this business have experienced that. And that kind of behavior, when the young people in our industry observe it from their leaders, becomes learned selfishness. They get to see, this is the game. You're nice here. And then when it comes down to the wire, this is the game you play to get as much as you can out of that one-shot thinking. So there's learned selfishness in this business, I think. And it's due to the hazard of contracting in a one-shot kind of way. What are your thoughts on that, Dee?
Well, I've really seen the moral hazard definitely go both ways. I've seen exactly what you're describing, where people are burning the bridge right behind them the whole way. You're just like, wow, are you sure that's what you want to do? Sometimes it works out for them. I've seen owners allow themselves to be treated that way over and over and over by a contractor, and they keep hiring them. And so they learn that I can treat these people any way I want and take advantage of them, and they're going to hire me back. I've also seen owners that will put you on their bad list after one bad experience, and you don't get hired. You won't even be considered for a job for a decade, 2 decades later. They're still holding a grudge. This reminded me when you were talking about it, the one shot idea of going back to what we've talked about in other casts about that quarterly earning or that short-term gain, whether it's the project or this one change order or whatever it is, the short-term idea of I've got to make margin on this project and I'm going to do it any way that I have to do it, or I'm going to make this margin on this one change order and I'm going to do it any way I can do it. I've definitely seen that happen with contractors. And maybe it's because they're going to get bonused off of the one project. Maybe it's because they're being pressured by their upper management that they have to make the next quarter's earnings. I don't know.
I think a lot of it has to do with that economic perception of this is the only time I'm ever going to work for this client. They only build once every 20 years in this town, or they don't build frequently enough for me to need to preserve this relationship. I don't see any value in this relationship. If they blackball me, fine. I'm going to get everything I can. I'm going to just fight, cheat, and steal to get whatever I can get out of this. Let's say we're talking about, since I'm in Detroit here, let's say I'm talking about instead a automobile manufacturing supply company, a tier 2 or 3 manufacturer that makes the reflective material that goes inside the headlights. I studied a company like that in one project. They're going to have to compete over and over and over again for Ford, GM, and Chrysler's business through multiple subcontractors above them. And if they get a reputation for being not people of their word in that very small, very repeat business, they won't get work ever, and that'll kill their business. If you're the subcontractor to the big GC in a small town like Colorado Springs, then if you burn that bridge once with that prime contractor, they won't work with you again. They'll have a hard time unless there's so few subcontractors that they have to work with you eventually. Then you get more leverage and you can burn that bridge. What does all that mean? Let's try and wrap this up into where I'm going with this thesis. So what does that mean about the state of the construction business? Well, I think it means that the built environment value chain is extraordinarily fragmented as compared to any other business practice in the United States. Design inputs end up coming from throughout the value chain at varying times. You get an architect and they hire engineers who provide changes to the architect's design. The main contractor provides changes to those designs. The subcontractors get on site and say, well, that detail is not going to work. We got to change this and that. So the design is constantly evolving during the construction process. And that value is important to capture, but it's difficult to capture. Expertise is commensurate. Architects are getting more and more narrow in the things they do. Contractors the same. Everybody down the value chain is getting more and more fragmented. And value, most importantly, is hard to measure at the time that we choose to write the contract. We don't know enough about what the building's actually going to be when that prime contractor is signing on, when the architect is signing on, to be able to say, okay, well, this is what that person's really going to add to this project. There just isn't enough certainties. We use low bid as our means of comparing. We use low bid to say we got the right deal, we made the right choice, but that might not have been the right choice. It might be that that low bid winner didn't have the expertise that you ended up needing, and that you should have gone with somebody that was high, but that was going to save you money in the long term because they had the expertise that was going to avoid the problems that the low bidder couldn't avoid. Those problems combine to create insurmountable, at least in my opinion, challenges at the time of contracting that end up being hashed out while we're in these moral hazard situations, while we're playing these one-shot games where we have these perverse incentives, where we have the opportunity to hold each other up. And that slows down the project when there are things that we could be doing to further the project, but we're thinking about our own individual needs as individual members of that value chain. We're acting not in the project's best interest because we can't afford to. We're acting in our company's best interest because that's what this environment has created a necessity for. I want to pause there and get any reactions you might have, Dee.
Listening to that description of the state of the business, I was trying to think of, are there any pieces of our market sector of construction that might lean more towards repeatability? Because that's really the problem, is that we don't have repeatability in our industry. It would be nice to think that we did, but in reality, if you've been out there swinging a hammer or turning a wrench, pipe is pipe, wood is wood, but we never build the same thing twice. I've built the same building for a client more than one time, and it still wasn't the same. We don't have repeatability. Even when we're trying to build the same thing for the same client on the same campus, it's different. There's different challenges with every single team. Even when we use the same people, have been involved in some of those experiments where it's like, well, look, let's take the same people, the same project team, and just move them over here and build it again. And it still is not repeatable exactly. Now, use shortcut things like relationships. Communication is improved because you've already worked that stuff out on the first job. My piece of the industry has always been large commercial and industrial. I don't build strip malls. I don't build Starbucks. I don't build residential. If I was building nothing but Jack in the Boxes or Starbucks as a career, I was working for a company that's like, hey, I'm going to go and I'm going to build 30 of these across the country. Is that repeatable enough to be capturing some of these productivity gains? I would still say some, but it's not going to be humongous still because your site conditions are different. The city that you're building in is different with different rules. And maybe they're a city that requires you to build it a different way because they have green building rules in that town where the other towns didn't have it. Maybe the permitting process is totally different and they want this, that, and the other thing added to it. And that's really the issue, is that every single thing we build, no matter how long you've been doing this, is different.
Totally. If you build a gas station in northern Minnesota, there's going to be different freeze-thaw lines in the soil than there are for the same gas station in Alabama. It's not as if we're going to apply a manufacturing solution and standardize and just say, well, you have to dig that deep in Alabama because you have to dig that deep in Minnesota and that's more efficient. No, it's not. The people building that gas station in Alabama build gas stations in Alabama. The people in Minnesota build gas stations in Minnesota, but it's not an environment that lends itself to the kind of standardization you see, and nor should it. I think one of the things that strikes me about architecture and about the built environment is that we don't want to build the same thing every time for the most part. Jack in the Boxes, Starbuckses, some manufacturing plants, some shipping distribution warehouses, perhaps, that makes sense. But the parcels of land, the geometry of those are different every time. The physical conditions on site, soil, freeze-thaw lines, trees in the way or not. But also our human want to have the buildings that we experience in our daily lives be novel and interesting and expressions of ourselves. If we think about the way that we build for the government, for example, the township of Pasadena's City Hall is going to be very different from the one in Honolulu, which is going to be very different from the one in Chicago, because the cultures associated with each of those and the needs that those end up expressing are very different. Not that everything is so culturally impacted as a town hall, mind you, but that's the kind of thing that could lend credibility to the notion that we don't necessarily want to build the same way every time, that there are unique rarities within each discipline that we want to preserve. Uniqueness is acceptable and even beneficial in the construction. Encouraged. Exactly. That's the word I was searching for. Thank you, Dee.
I would say in my time doing this, I've seen huge changes in even what's included in a type of building. I've built dozens of lab buildings for the same client over and over. The buildings are not the same, but they are different kinds of labs. They're different users. They're different applications. But even things like restrooms are different. We used to only do what are called gang baths, which is where you walk in and there's multiple toilets and lavvies and the whole thing. Then there was a cultural shift to we want to offer single. Now we have to offer mother's rooms. That's a current thing. Like 30 years ago, 20 years ago, even 10 years ago, we didn't necessarily build a mother's room into a new building that we were building, but now we're putting mother's rooms and they're needed. Absolutely. I'm totally on board. But that wasn't even a thing 10 or 15 years ago. And now it's going in every kind of building that we're building. So the design requirements change, the codes change. Depending on what state or jurisdiction you're building in, the code requirements might be different. Somebody's building by IBC, somebody else is building by a local state or jurisdictional code. So it's just not the same. I worked for a company, a construction company, that decided at one point, and I have no idea what the logic was here. I was merely a project engineer at the time. They decided to get ISO certified. And I didn't really know a lot about ISO certification at the time. So I didn't really understand what a massive waste of time, money, and energy this was until a little bit later. And they did it in a bubble. There was somebody who proposed it. Management accepted it for whatever reason. They hired this European company to fly in, spend all this time writing up all these SOPs. And this is a mechanical contracting company. We're building 50 different jobs at once, and every single one of them is unique. And yes, there's a fab shop element, but still even that's as close as you could come to an ISO environment, but I still don't think it lends itself very well to it. Anyway, they went through all this expense, and then you have to get this inspection. And at the end of it, and again, with no input from anybody who actually did any of the work, came out with these huge binders of documents. We're ISO certified now. Here's your binder of how you're supposed to do things, how you're supposed to run your projects. And I remember looking through it. There were forms I'd never seen before, forms I'd never used before, processes that didn't really exist out in the field for conditions that didn't really exist out in the field. And I just remember handing it back to him and I said, this is garbage. I don't really understand what's happening here, but I can tell you this is not how things are done in the fab shop. This is not how things are done in the field. Are you telling me that we're supposed to try to comply with all this stuff? And they said, yeah, you need to comply with it. And I just said, I don't know what to tell you. This is just not how work is executed in the field. And I have 3 jobs right now, and I can't make this fit with any one of my 3 jobs. If I have to do all of these things, some of these things, like I don't understand. Anyway, it lasted about a hot minute and the whole thing was canned because I think that's a really good example of leadership not really understanding. I don't know what the conversation was. Maybe they didn't understand what the finished product really was. Every job's a little different. So what applies to a $500 million job may not apply to a $500,000 job.
What I love about that is so emblematic of the way that the office sometimes thinks about the field is that it's like a 0 to 100 solution. Like, we have no standards now. Let's make our standards ISO. Let's go all the way over here. That's just there's no iteration there. There's no evolution. It's just, we're going to make it, and it's just going to be because we said it will. Brilliant. Thank you for sharing that, Dee. So, okay, all of this to say that the solution is not for us to standardize the buildings we build to make them all look the same. It's not to standardize the same exact way that we do things in the field every time. That is not the solution. Turning the construction site into an assembly line and trying to build the same exact way physically every time is not going to be the industry's path forward, as much as some people have tried to make it that way, in my opinion. The solution I would like to propose here is to rework our contracting and management practices to adequately account for the increased fragmentation that we experience in the construction industry and the contracting hazards that we discussed. There are some technologies that we can use for this. One of them that I think has the most promise is building information modeling. Before we were recording this, we talked about how difficult it was to bring BIM into the construction industry, having to go from 2D drawings into this 3D modeling space. I think we need to go further than that. I think we need to go from the 2D drawings that we still share with contractors as contract documents to 5D construction models, where not only are we talking about objects in 3D space, we're talking about how much those things cost because there's specifications linked exactly to that product, not blanket this window unless otherwise noted. And then you have to check the documents and all this kind of coverall generic stuff that you see in specs. You click on it in 3D space and it has the exact model and make of that window, of that duct, of whatever you're buying. And it's going to tell you when that comes in sequence because it's all there. It's not cross-referencing the 3D plan to the schedule, which was built in P6, to the budget that was built in Excel. It all needs to be in one place so that we can manage it as a team together and not have separate sources of truth, not have multiple different reflections of the same physical identity. The other solution I want to propose is trying to design for a different set of stakeholders at each step in the design process. We act in construction as if once the architect says the design is done, that's it, the design's done. It's not that the contractors that come onto the site are going to develop their own solutions. What the architect said is going to go unless there's some huge problem. And then the architect will get a request for information and then we'll deal with it then. We need to recognize in the way that we contract and in the way that we collaborate that design is an ever-changing process, that once that contractor comes on site, that once that expert in tile takes a look at these drawings and is under contract to perform on them, they're going to have suggestions that are going to be better for the project. This adversarial relationship we create where once the architect is quote unquote done with their contract, questioning their design, offering suggestions, offering improvements is somehow some new process that has to be dealt with. And it is so counterintuitive to the way that we think about building, to the collaboration that we naturally lean into until we pull ourselves back and realize the risks that we take on because of the way we write our contracts. So what I propose instead of the process we have now where architect stops and contractor begins is for the architect to design for a model of what the owner wants to experience in virtual reality. Get an owner in VR goggles, have them joystick toggle walk through a building that the architect has built for them and say, yes, this is the kind of building I want to be in. I want the windows here. I want my lab with desks at this height. I want to be able to reach this outlet at this point. This is what I want to experience. Then turn that 3D model that was probably built in Revit or BIM over to a contractor so that they can help make that happen, make it possible to build that. And then let them, during the pre-construction phase, when you're getting out of the ground, work with their subcontractors to continue to evolve the details and work with them collaboratively. Let the contractor own that design for construction process and own a lot of the code compliance because the contractors end up being the people that know the code anyway. They're dealing with the on-site inspectors. They're dealing with the city when they pull permits, not architects. Architects are dealing with the human facets of design, the way that we experience the building, but they're not, even though they're contractually responsible, experts on code compliance, the way that that master builder, that person who knew all used to be back in the 30s and 40s. So those are some of the solutions I see. I would love to hear your reactions to those, Dee.
You bring up some interesting ideas. One of the challenges mechanically that I'm aware of with the BIM, going back to the BIM proposition of having a complete BIM model that has the exact thing so that everybody's on the same page. I don't think you're the first one to propose that. It is a great solution, but I think the challenge with it is from a manufacturing standpoint, and this is now we're talking about fabrication manufacturing. So ductwork, piping, and I don't know about other trades specifically, but on the mechanical side of things, each contractor has their very own BIM database for parts, components that they've built from scratch or purchased from somebody else. But every contractor that I know of has built their own from scratch. And it's what their internal people use. The challenge with taking a BIM model that somebody else has made, particularly a designer, is first of all, designers don't do BIM models for reality. They do it for an idea of what something's going to look like. So as a mechanical contractor, when I get a BIM model from a designer, they've got odd duct sizes in there. They've got odd angles for piping that are custom angles because they don't know that even though it might need to be a 29-degree elbow to make that fit, that's a custom elbow that costs a fortune. Can I find another way to do that where I can use a standard elbow, where I can get it to a 45, or I can get it something else so that I'm not making custom angles everywhere I go, which of course costs more money, reduces productivity. So, and having their own individual databases that they've built from scratch really necessitates having to take that BIM model that you inherited at 30% or whatever from the design team and start over again. Yeah. And it's one of the massive inefficiencies that we have with BIM is that we've got these people doing BIM over here and kind of giving us an idea of where things are going to go. And then the contractor really does the deep refinement. We've tried different experiments in different projects with having the contractor do it from the very beginning and not even have the design team engage. Didn't work out great. What ends up happening in BIM, a BIM expert could probably give you a lot more insight on why this happens. From where I sit, and this is maybe not going to come out the best way, but we get BIM lazy at a certain point. And that's not intended to be a knock on the people that are doing the BIM. It's very hard work. I know that. And there's a ton of detail and a ton of work in it. But the outcome is we don't end up modeling everything. It's too much work. We don't want to do it. It's too much detail. We fight with the electricians all the time over this. They don't want to model any conduit that's less than 4-inch or something like that. If they don't want to model the spaghetti, well, guess what? It's in the way every single time. Every single time. It's the spaghetti conduit. I am a firm believer that the best BIM model is going to be the BIM model that has absolutely everything in it. Now, is a BIM person going to agree with that? I'm going to wager no, but I wonder if anybody's ever done a study. What if we did model absolutely everything? And obviously this is easier in a brand new building. What if we modeled absolutely everything and clash detected absolutely everything? And then of course everybody has to put their stuff where it's supposed to go, where it was set to go in the BIM model. That's another challenge we have out in the field. You can have the best, most perfect BIM model in the world, but if people don't install in the right place, it doesn't work.
Steve, do you mean to tell me that sometimes the BIM model doesn't get implemented in reality the way that it was designed in BIM? That's crazy. I've never heard of such a thing. You got to be on cloud 9 out there.
That's always my first question. When I get somebody coming to me out in the field and saying, this is clashing, this isn't in the right place, this isn't working, my first question is everybody in like they're supposed to be? Is everybody in at the elevation they're supposed to be, in the place they're supposed to be? Or if we have things that were not modeled that are in the way. And that's usually what happens it's investing in the front end. Boy, this sounds a lot like our design conversation, Brad. Investing in the front end in getting all the modeling done. What ends up happening in the field, and the BIM guys aren't involved in this stuff, so maybe they don't know that how often it really happens, is we either get people that never modeled that are just putting stuff in the way of the thing that is modeled. And there's usually a contractual clause in there that somewhere says that if you put something in that isn't where it's supposed to go, it's your responsibility to move it. But how long did it take you to find it? Because I've had that happen many times. You've got layers of stuff in the overhead. Well, somebody way up top in the second layer didn't put in at the right elevation. Maybe they couldn't for some reason. Well, they didn't tell anybody. They just kept going. Well, everybody that came after just kept going. And the next thing you know, you get 6 layers down and you're into the ceiling. Now what do I do? Do I take out 4 layers to get to the real problem? Or do I lower the ceiling?
And the owner will kill you if you lower the ceiling.
Stop me now if any of this sounds familiar.
We should have given a trigger warning. Maybe we can edit this podcast to give a trigger warning at the beginning of this podcast for like the things that people have said and the arguments we've had, because it's all happened over and over again. That's such a great point to bring up, Dee. I think that I've seen that on many projects I've worked on where the engineers, the people in the design phase who are the stamping people of record, get into BIM and design how they think the duct should be. And then the duct guys go, no. And we're doing it our way. Maybe you get to some kind of world where it's a parametric thing of, look, we've calculated there needs to be this much CFM in this room of supply and this much CFM of exhaust. You figure out how you want to do it. But we think you should have grills here and here. But really, there's a parameter that we can set you up with that as long as you check that box digitally, you've done your work and we as the engineer will sign off on it. That's obviously not how we stamp drawings at the city, because the way we've always done it is if the register is not there, then the inspector is going to say, you're not in per your plans. They're going to walk off the job. So maybe there's a flexibility that needs to be built there with the authorities having jurisdiction, with the people out inspecting our work, to be able to say, yeah, we know it's not per that plan, but look, it still meets it from a parameter standpoint. Oh, okay. The fine point I want to put on this is that the perverse incentives we see in the construction industry due to this specialization that has caused there to be all of these different parties, all these different members of the contract, does not incentivize us to solve these problems in a collaborative, constructive, everybody better for a better building way. It incentivizes us each to look out for our own piece of the pie and contribute to the pie growing when we can, but to look after our own slice of that pie first. And until we can get to an environment where the whole industry operates on a vastly different set of standard practices when it comes to design and implementation and contracting, that's not going to change. Just to be able to prepare for this podcast, I couldn't get data about how many projects go over budget, about how many projects experience this kind of contracting problem, because most of these contracts are so private and the people who engage in them want to keep the results of those contracts so secret because they often go very badly, that they're such dirty laundry, that they're not good to air in public. The nature of the construction environment is what's making it so difficult for us to solve these problems. And until we go out into some kind of a lab environment where we say, all right, that's it. We're just going to do 20 construction projects in a row where everybody works for the same company. And we're going to try different organizational structures. We're going to try different contractual relationships. We're going to try different technological tools in the field and endure the new thing being much more expensive than the old thing for the sake of making that technology work, because we know eventually it's going to be the thing that we use. We're going to learn the lessons we need to learn to make it more efficient in 10 years. Until we make those kinds of investments and decisions in this industry, we're going to see this flat productivity because no one party can be incentivized to work hard enough for payoff to realize the benefits of that. It's the kind of thing where it's an all or nothing type of ordeal. That's a very wicked problem. I don't know how to solve that problem. I think that there's some kind of a government research lever that needs to be pulled there to say, much like we do with solar panels or lithium ion batteries, we're just going to invest this money because we think it's the right thing to do, and we're going to hope we get a great outcome. But we don't know if we're going to get a great outcome or not. I couldn't stand in front of a committee of people and say for sure that I'm going to invent the future of construction. Somebody gave me $5 billion tomorrow to go try this kind of a thing on 10 different commercial construction projects over the course of 10 years. But I think that's what it's going to take to move the industry forward, unless we come up with something more brilliant than I could come up with. Speaking of the money, that I found a very interesting statistic that surprised the heck out of me when I read it. Between 2020 and 2022, private equity and other sources invested over $50 billion in AEC, architecture, engineering, construction, tech. 3 years, $50 billion. Are we seeing the kind of technological improvements that $50 billion might expect it to bring? I don't think so. I think that's money that is not going towards the big solutions yet. I think that there are application problems with a lot of those solutions that are not allowing them to have the traction that people hope they would. But that's all I got. That's my thesis after all this time here in business school, trying to figure out what's going on and how we can solve those problems. Any last reactions there, Dee?
Yeah, I think the $50 billion investment is a long-term investment. And I would hope that we're learning a lot in the spending of that $50 billion. I've definitely seen some things tried on various sites that I've been on, or things that are helping. So I had one remote project last year that it was a building that had flooded, and it was in a very hard to get to place. And what they did was they went in and did like 3D video and photos and everything and put it all together in this model so that people like me from far, far away wouldn't have to travel to the site, and I could look up equipment tags, serial numbers. I could see water lines. I never went to the site. I was able to help design a refit of this space, a gutting and refit of this space with that technology, and I never had to go to the site. So there are things that are happening. I think your overall message is this is the dream of design build. This overarching message is this is the dream of design build, is that we're going to use technology, we're going to use our people skills, we're going to use our collaboration, and somehow figure out how to pull all these different levers. I think the problem is we're not looking at one lever. We're looking at 100,000 levers that need to be pulled at the right times and in the right places and in the right situations to gain these productivity impacts, positive impacts and productivity. And we haven't figured it out yet. I've seen design build used incorrectly, improperly, uncooperatively many times. I think the dream of design build, part of me wants to say it's dead and we need to go back to design assist because that was working well. That was the thing we did before we got all the way to design build, was we did design assist. Every design assist job I was ever on worked very well. It was very collaborative. We had the right attitudes, less selfishness, less in it for me, I'm going to make a bunch of money on this job. And it was more like, hey, trade specialists, how can we do this better? The design team was open to collaboration and input. When we got to design build is when it got jiggy. And I think maybe we're not quite ready for all that. Maybe our egos aren't quite ready for it. I don't know. I think it has the potential to work well, but I've not seen it do great so far.
I love that. I think that's a really cool reaction. I've never been on a design assist project. I've only ever been on design build that never felt like design build, or design bid build that felt like a war. And that design assist environment sounds really exciting. I think that that's the kind of stepping stone that maybe we didn't spend enough time in as an industry based on your understanding and experiences with it. So that's fascinating to me. This is something that I was really passionate to try to put together. Thank you, Dee, for giving me a platform for my ideas here. I'm not sure that I'm going to be able to implement these ideas right out of business school. There aren't a lot of people trying to do this work, and if they are, they're not paying, or I haven't found them yet. But it's a lifelong journey. I think over the next 30 years, this is a dream of the construction industry that we need to try to realize to be able to solve the huge problems that we face, that we could solve if we could get past some of these built environment problems. There's a lot of counter arguments to this that I can hear people making of like, just what Dee said, like, well, I don't know about that. I don't think you could ever do what you need to do from remote. That's crazy. I can hear people I've worked with having that kind of reaction to that. But I think the more vile moment to pause and think about is, what is this technology going to do to the people that work in this industry? Are there going to be people that cannot find a job in this industry anymore because jobs are going to be cut because of technological efficiencies? When people say the word Luddite, you think of somebody who's anti-technology, who wants to stick with something from the past because the new is too complicated. But the Luddite revolution was something that happened in Europe a long, long time ago, where people that had woven sweaters by hand and other textile garments were so displaced by the advent of the loom. They were so economically displaced by the advent of the loom that they burned the looms because they were not going to have a way to make an income. They didn't have access to education to be able to get another job. They didn't have access to different environments where they could find other non-skilled work. So they burned the looms so that they could feed their families and so that they could continue on in the life that they had known. When we talk about progress, when we talk about technology, we have to be conscious of the people that we might disrupt. I think in one of our previous podcasts, we talked a lot about how globalization has left people in this country behind. And that kind of problem is wrapped up in the meat of what I'm talking about here. And it's something that cannot be ignored. I just wanted to add that on as something that is worth thinking about in the mess of all this.
Productivity gains or no productivity gains, tradespeople are needed. Electrical is one of the biggest growing fields right now. If you want a job, anybody out there, you're looking for a job that's going to make you some money, be an electrician, be a plumber, be a pipe fitter, be a carpenter. Building's not going to go away. Infrastructure jobs are not going to go away anytime soon. And joining the union is the best pay and benefits that you're going to get. And it's one of the few things that still offers pensions. Government jobs and union jobs are the only pensions left out there, I think. So it always hurts my heart when I hear people say, oh, there's no good jobs out there. There's nothing that pays well. That's absolutely not true. Construction is a very skilled and well-paying job. And in the union, they earn while you learn. So you can't beat that with a stick. Thanks so much for joining us today. We'll talk to you soon. Watch us on YouTube at YellowstoneProfessionalEd.co. Don't forget to like, share, and follow us, Apple, Spotify, everywhere you listen to your podcasts. You can email us with questions, comments, and suggestions at heyd@managementunderconstruction, HEYDEE, to get me or Brad at managementunderconstruction.com.